So just a word about strong bases and weak bases and what they look like in chemical equations. So strong bases, like strong acids, are going to fully dissociate in water. That's going to allow them to conduct electricity very well. We call them, they would be electrolytes, just like table salt is an electrolyte. Weak bases. Strong bases are going to be alkali hydroxides, so sodium hydroxide, potassium hydroxide, etc. There are 3 alkaline earth metal hydroxides that are strong bases, and they are stacked on the periodic table: calcium, strontium, and barium hydroxide. That subscript there, that 2 hydroxides per metal ion, that can be a little tricky later on. Weak bases, other proton acceptors. So this hydroxide is something that can take a proton and make water, but there are other proton acceptors too. A lot of them have nitrogen. This one is ammonia. It's very aqueous. Right? If you've ever worked with ammonia, you know it's very smelly. This methylamine, etc. Disregard that. So, for net ionic equations, I have a strong base plus a strong acid. I have another strong base plus a strong acid, and then I have a weak base plus a strong acid. So we'll take a look at what the net ionic equations look like. Strong base, so I'm going to split it apart. Strong acid, so I'm splitting it apart. Dissociating the ions. Okay. And then I can get rid of any spectator ions. I see sodium. Oh, very good, you caught that. So we got sodium. We got to get rid of sodium ions. They are spectator ions. And chloride ions are spectator ions. So we end up with hydroxide plus hydronium, or plus H plus, gives us, plus a proton, gives us water. Next one is calcium hydroxide plus 2HCl. Calcium hydroxide is one of the strong bases, so I'm going to dissociate the ions in water. That 2 is a subscript here, but it's going to end up being a coefficient. There are 2 hydroxide ions. Now I have a 2 here in front of the HCl that balances this equation. I have 2H plus. Pay attention to those subscripts. Anytime you have more than one of those ions, when you write an ionic equation, it becomes a coefficient. So I'm going to look across and see what spectator ions we have. I see calcium on both sides, so I can get rid of that. Then I have 2 chlorides on both sides, get rid of that. And I see the net ionic equation looks like 2OH plus 2H plus yields 2H2O, but the coefficients are all the same, so we can reduce that. So your net ionic equation actually should just be that. So I'm going to put a star there, because that could be tricky sometimes, right? It is the same net ionic equation as the other strong base. Last one is a weak base, ammonia. You should remember NH3, you should know that formula. Ammonia, nothing breaks apart when we put ammonia in water. HCl does. If we look at the product side looks a little bit stranger than sometimes. We notice we have 2 charged species on the product side, whereas before everything is neutral, 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 neutral. This one we have, I guess I've already dissociated. That's a better way to write ammonium chloride, NH4Cl. So we have an ammonium compound. Ammonium compounds are soluble. So you should go back, make sure that you have this written down for your product side of your weak base plus your strong acid. You really do want to write things that don't have charges on either side, and so make sure you correct that. When you dissociate it, you get ammonium and chloride. Now we get rid of spectator ions, and we get that. We get ammonia plus a proton gives us ammonium. That's your net ionic equation for a weak base plus